Today we're going to take notes on probability versus odds. So let's write that on top. We've been talking a lot about probability. And today we're going to introduce odds. So probability versus odds are not mathematically equivalent. Okay, they're often used interchangeably in casual conversation. However, they're not mathematically equivalent because they are looking at the likeliness in different contexts. So, in everyday conversation, when numbers or values aren't given, the two terms can be used interchangeably, such as like if an event has a high probability, then it has high odds for happening. The incorrect usage arises when a person puts mathematical values to either the odds and the probability that they're discussing, and they're saying that they're the same. So hopefully these notes are going to clear up what the difference is between probability and odds. So we have a bunch of dots. We have 6 blue dots, 3 red dots, 2 yellow dots, and 1 green dot. Before we deal with these dots, I just want to go over a couple different rules with probability and odds. So probability, you just took a quiz, so you know a lot about it. It's defined as a fraction of a desired outcomes in context of every possible outcome. And it has to be between 0 and 1. Sometimes it's given as a decimal, sometimes it's given as a percent. As for odds, odds can have any number, any value from 0 to infinity. Okay, odds are ratio of the desired outcomes versus the field. Odds are a ratio can be given in two different ways. We can say in favor. So what are the odds that it's in favor of an event happening? Or we can say the odds are against. So odds against. And that would be the odds of it not happening. Okay, so let's go back to probability here. When we have the probability of event A occurring, that would be the number of event A's on top over the total number of events. For instance, if we look at these dots, let's say we want to know what the probability is of getting a red dot. So probability of a red dot or marble, whatever you want to call it. Okay, well, we would say 3 on top because there's 3 red dots out of the total number of dots. So 6 plus 3 is 9 plus another 3, we have 12 total, and we would give that as a simplified version, either 1/4 or you could say 25% for your probability. Now, when we're talking odds, it's a little bit different. If we want to say, what are the odds in favor of getting a red? Well, you would tell me the number of red marbles. So it would be number of red dots, or we'll say dots instead of marbles. And then it would be a ratio, and in the denominator, the second number would be the number of non-red dots. So we would have an answer of, and I'll shrink this down so we can see it, the number of red dots would be 3, and the amount of dots that are not red would be 6 plus 2 plus 1, so we'd have 9. So the odds in favor of grabbing a red dot out of all of those would be a 1 to 3 odds in favor. Now, if we were going to do against, so let's do odds against getting a red dot, literally just the reciprocal. So we would have the number of non-red dots on top and the number of red dots on the bottom. So 9 over 3 simplifies to 3 over 1. Let's get a little bit more challenging and move on to the next page with harder problems. Example 1 says, if the probability of rain is 40%, what are the odds that it will rain? So it starts off talking about the probability and then it wants to switch to odds. Okay, well, if we have 40%, I like to think of this as 40 over 100. And let's simplify to, well, you have 4/10 that can be simplified to 2/5. Okay, so the probability that it's going to rain is 2 out of 5 or 40%, whichever way you want to think about it. I like to get whatever the percentage is into a fraction because this is telling us the amount. So times it will rain out of total times. Okay, so if we have 5 times that something's going to happen, 2 out of those 5 times it's going to rain, that means 3 out of 5 it will not rain. Okay, well, what that's telling us is if we have 5 things, 2 times it's going to rain, 3 times it's not going to rain, and now these are the numbers that you use for odds. We don't use the total. So what are the odds that it will rain? That would be 2 over 3 or 2 to 3. That would be how you get your odds. All right, let's look at example 2. If the probability of rain is 40% again, what are the odds that it will not rain? So again, instead of rewriting everything, let's use this information, okay? And this time we are going against. So we want the part that's against it on top, which would be no rain, that's 3, rain, 2. So then your odd is 3/2 or 3 to 2, which realize it's greater than 1. All right, example 3. If the odds that a person will not become ill with the flu are 6 to 11. So this time they're starting out with odds. So if the odds that a person will not become ill with the flu are 6 to 11, what is the probability that a person will become ill with the flu? Okay, so let's start to dissect this. So first of all, our odds are 6 to 11. You can always write it like that. So we need to figure out what's the total number that we have, because in probability, remember, probability, and we are becoming ill, so probability of getting the flu, it's going to be whatever number we'll figure out there over the total. So flu over the total. So let's figure this out. The total number, when you have odds 6 to 11, that means that our total number will be 17. So that's going to go on the bottom. Now, they gave us the odds that a person will not have the flu. Therefore, the person getting the flu would be the 11. So the probability of getting the flu would be 11 over 17. Last example. If the odds, so we're starting out with given the odds, if the odds that a person will not become ill with the flu are 6 to 11 again, what are the odds that a person will become ill with the flu? And this one's pretty easy. It starts with odds and ends with odds. So if it says 6 to 11 that you will not get it, well, then the odds of getting it would be 11 to 6.